Okay.
Let me see if you can.
It's in the zone.
Okay. Great. Who else do we have on the line?
Hello, Jonathan Chechik. How are you?
I'm doing well. How are you?
Well, thank you for taking the time today to do this. Appreciate it.
And it looks like we also have Solomon. Are you online?
Maybe.
Okay. Okay, so let me go ahead and share my screen. Okay, can you see my screen? Perfect. So I'm going to show a little example on classification. Can you just join?
Hi, this is Sam Sussman.
Oh, Sam. Hi, Sam. How are you?
Good, how are you?
Well, thanks for joining us.
Sure.
Okay. So the example I'm going to show is going to use it's on classification, and it's going to use our part. I'm going to be using the RStudio for that. I don't know if everybody's using it, but essentially it's the same as the regular R interface. First thing, we're going to install the art. And done, we're also going to install the rpart plot, which is the graphical package. Okay. So for the, again, just for those who just joined us, we're going to be looking at the example of classification and use the rpart library, and we can use that, which comes already with R. Just quick show of hands. How many of you are familiar with what Iris dataset is? Okay. So essentially, if any one of you ever done, or at least attempted to learn how to program, we'll start with the Hello World application. This dataset is essentially a sort of analog of Hello World application, if you can compare these two. It basically contains data, 150 observations on hours. It's a very popular data set. It's very basic, so we're going to use it for our session. So go to Iris data set. In the value section, it appears our data set is loaded. So essentially, like I said, it's a data set that has species of flowers, 150 observations, and if I'm not mistaken, it's about 5 variables. Yeah, so yeah, it's 150 and variables across the board. Here we're to predict the variable, this one, and it's a categorical. It has categorical variable, and it's the mixture of the flowers attribute variables like the length and width, sepal and petal. So let's build a table with the variable. So this categorical, we are in the techniques of supervised learning. Use KNN, naive Bayes, but for today's example, we're going to use classification. The thing we're going to do, and I'm sorry, I think somebody else has joined us. Has he joined us? Okay. Now, okay, welcome. We're working on we're looking at the example of classification using IRIS data set and library. So the first thing we're going to be doing with the data set is we're going to pre-process it. So let's look at the head of our data set. So here we have, it looks like data set is in somewhat pre-processed order. So we have those first, and then we have versicolor, and then we have Virginia, etc. So in the pre-processed order, in order to introduce element of randomness, we're gonna set the seed, and it's essentially what we're gonna do with this. It's like creating a bunch of numbers in the cards before you play. So shuffle it before we do anything further. So we're gonna set the seed. Let's give it. Okay. So now I'm got a bunch of numbers, as many as the number of rows I have in my data set. In fact, it has 150 rows, but we're only going to use 100 of them to create a data set. And we're going to use another part of the data set for testing purposes. So, let's see. I will use variable, the G, as to IRIS dataset, and we're gonna call it as R, reordered. I'm gonna use our variables assign the numbers to. Okay. Now that we have our data set reorder, our reordered data set is right here. It's called IRIS R. Now we can use the rpart package to build classification tree. So, algorithm that works similar to LM function, if anybody's familiar with it. Essentially, you're calling the function, and you're specifying your target, and then then your predictors. Go back and look at the structure of IRIS data set. We're going to see that our target is speed. Predictors are these variables right here. So I'm going to call the function. Typically, the way you call it, first you indicate which is speed, then put the sign, and then the target of predictors, and which would in in our case, mean using and connecting them with the plus sign. Absolutely. I mean, if you have too many, like in our case, we only have 4 predictors, but alternatively, if you have too many, you can just, instead of all these, you can just use the period to include variables, include variables instead of listing all of them. So next thing we're going to do, we're going to list the data set. It's going to be R. And here we need to, instead of looking at the whole data set, like I mentioned earlier, which is 150 observations, let's look at the first 100 and remaining 50 for testing purposes. So in other words, we're gonna create a training data set, and we will add the we will use the remaining data set for testing. So we're gonna list just the first 100. And we need to list the method, which would be classification. Here we go. So what we're is we have n as the number of observations. Then we see the headers of the table. So in other words, we see the nodes, essentially node is the node number, like 1, 2, 3. The split is where feature was split on. Then how many observations. It's misclassified. How many were misclassified classifications, and then why that was the prediction if you were to stop at that observation. And yeah.
Thank you. Before we get too far, I did have a couple questions, things that had confused me from the videos and relevant to some of the parts that you were talking about here. Because some videos were referring to R part. Others seemed to point to using tree as the function. It was never clear what the distinction was. You're saying that R part is a library. Is that something that we have to load into RStudio? Or
yes, I did look earlier. And ARP is the aspect of it's the most used library by data scientists. I mean, there are numbers of other libraries that you can use, but to just using ARP. Did load it at the beginning right here, and loaded the RPart plot for visualization.
We're complete newcomers to that. Do we have to go find that somewhere, or how do we find it in order to install it?
Once you have R, it comes, if I'm not mistaken, it comes with R, but I'm using RStudio. And
part of it?
It's already part of it. You just have to, install and load it. Part of it, but once you install it, knows where to go and download it. Then
it knows. Okay.
Right.
Good. And then some of the videos also use that set.seed function, but others didn't. So you're saying that we have to shuffle the records in that data set. Is that something that we need to do every time, of just putting in some random number there for set seed, or?
Not necessarily. Like I said, in our case, we're using Iris dataset, which is more or less in order, I should say. So you see, like the value we're going to predict already kind of like in the right order. Setosa comes before versicolor, etc., etc. So to create a random data set, we introduce this seed. Okay, so we had no errors, and we look at this, the star at the end of each observation, that refers to a terminal node. And to the leaf node. So, so if to draw it, actually, we would go and start with this one, root. And actually, our first that was branch petal, and essentially everything that's less than 2 points would go to that branch, and one would go to let's run the R plot and just look at it. Oh. So I have the R part, but would be more efficient if we assign it to variable. So we could use that variable in the in building graph. So let's rebuild it. So now we have M3 that 14 observations in there. And so now we're going to look at the plot. There was an argument. We have visualized the output of the IRIS dataset, and tweak it a bit. So introduce more options. Okay, so with these options, essentially, type leaves are, well, we're missing the head nodes, and it's not that it was excluded, it's just not in this, it's not presented. And right leaves are pure. You can see that there are no errors. Leaf has 2 errors, it looks like. Summary output of this so it has 37 observations, and it has 2 errors right here. So the last 50 observations we have left in the data set to see how well this model rises to a new independent data set. We need to make a prediction first. So, and we'll variable P3, let's say, and we use going to use classification. Okay, so we assign the prediction to this variable, and now let's make a confusion matrix to how well did that will do. So actuals. Let me just ask: everybody familiar with the confusion matrix? Familiar with the confusion matrix?
Or two into it.
Okay. All right. So essentially, confusion matrix lets you see how many corrects we had and how many errors we had. List your actuals. It's a table where you list your actuals on the left side, sort of like the vertical side of the table, and the predictors on the top side, the horizontal side. And across of it, you can see the which one were correct and which ones weren't. So let me show you how it looks. So we're going to build a table. Then you use this column. Essentially, that signed set a color similar to Virginica twice on both, and that error that we have here. Yeah. Do see a match here with Setosa 16 times matched Setosa 13 with Versicolor, Sans with Virginica. So we didn't do bad with this algorithm. We corrected predicted 16 Setosas, 13 Versicolors, and 17 Virginicas. About the two errors that we had, and the $2 that this model predicted to be Virginicas. Like I mean, the outcome wasn't that bad, but in some other cases where the errors are much more other classification algorithms, for example, C5.0. And then essentially you will look at the number of errors that comes out of C5.0 prediction and compare it to prediction that gave given to you by BART, and you will make a qualitative decision on which algorithm suits for this data and for your purposes. So, anybody got any questions at this point?
Question. So, kind of piggyback off of Brad's previous question about all the different algorithms that we have to choose from as far as classification sets. I got the impression from some of this initial discussion at the beginning of the year that we're looking at random forests, and random forests are obviously an ensemble of all those classification models. Is there a point in time where you would prefer to utilize the R part as opposed to the random forest model? It made it. My aim was that the random forest model was kind of the catch-all model, but I could be mistaken. Really,
essentially, our part is a required part of random forest. Well, let me start with random forest is a favorite technique of data scientists. It's a non-linear method particular and very useful in making predictions. It partitions the data set into small subsets, and that's an average for those subsets, and that's the regression value. It works as a large collection of decision trees, essentially. Reason random forests are the favorites of data scientists. They're fast, efficient, they work great with missing data. Our part is essentially part of random forests. So we try going through an example of random forest with the same data set we have. So ISR, that is essentially randomized 100 first observation from IRIS dataset randomized. So we got to
And explain what the record function is. I don't remember seeing that one before.
it keeps the when you do something and you close the session. Essentially, it keeps the live in available by default. You don't have to. So. But technical difficulty here. Let's see. Okay. So, let me actually make a better example. Let me research this a little bit and make a better example for the next session. But essentially, you would our part, and then you would use the random forest function. Essentially a random forest function on data you built with our part. But I'm going to make a different. I'm going to make this as a topic for the next.
Okay. Thank you.
Got any questions? I think somebody had. I think Susan had tuning, and if I'm mistaken, she's been asking in her classifications, she put a model, and the model she received after that had more errors that the model was asking. That's normal, and it is normal, essentially, through complexity of final classifier. And that's supposed to improve the predictive accuracy. But a small tree might not capture important information about the sample data set. So.
So one more question.
Sure.
So just conceptually speaking, as I'm reading through all of the documents and Perplexed and whatnot, and to get your thoughts. So, I understand the concept of the root node and then the splitting of, the attribute essentially gets, the best attribute gets selected and then you split into separate nodes. Beneath that, I'm trying to get my head around, what identifies that attribute as being the best? Is that the GINA index that I'm kind of...
Jonathan, can you repeat one more time? Is that part of...
Yeah, I was reading a little bit about the what's called the GINA index, GINA. That's, looking at the calculations and the percentages within that, and then, obviously the one that's closer to 0 will be selected. I'm just trying to wrap my head around of how, to read the best attribute when it splits in random forest. So,
to read an attribute?
In random forest, you can select a certain number of attributes into separate decision trees, right? So
right.
It's essentially identifying that 100 different attributes, identifying which root node to select. So, if you have a number of trees, which tree to essentially select and know which one is the best tree to go through.
Well, normally the algorithm is supposed to do it for you, but Jonathan, let me research that a little better, and I will make it a part of a WebEx session next time.
Thank you.
If I might, I had a related question. I'm under the impression that yes, our programming is doing that for us, taking all of the possible attributes, seeing which one has the purest split, and just taking whichever is the best one there. But I guess those attributes can be a variety of types. Some are continuous, some are nominal, some are ordinal. Mm-hmm. So as it's going through all of that, it's looking not just at those discrete attributes, but is it from the get-go looking at those continuous attributes and trying a variety of different splits for where you cut it into two different parts?
So if it's looking at one attribute, it then compares it in random forest. It compares it with the same attribute in different trees. That's how it's making the decision.
But even just the basic R part, it had to take step one, figuring out what the root node should be. And so isn't what it's doing at that moment under the hood, it's testing each and every attribute to see which one should be the root node. Not the case then. Okay, I guess I'm misunderstanding how this is working.
Elena, do you want to take on that one?
It's looking at the information gain. That's how it does. That's how it decides which attribute is the next split. But basically, for the continuous attribute, there is something called internal discretization, so to speak, and the decision tree algorithm decides how to partition the range based on the values of the continuous attributes. So there's something that's going on like an internal algorithm that discretization, yeah.
So if the widths can range from 0.3 to 2.1 or whatever else, it has some methodology for deciding from the outset what is the appropriate split for petal width, and then goes from there to see if petal width versus petal length versus everything else deserves to be elevated to the level of root node.
Yes. Yes. Information gain is one of the methods that it's using to determine the splitting attribute.
Okay. Thank you.
And if I'm wrong, it appears that the assignment that we're kind of going through is due on Sunday. Is that correct? So when we're talking about subsequent WebExes, we're looking into probably next week. To be clear and just make sure I turn assignment on. Is that correct?
Yes. This is yes, that's correct.
Okay. Okay.
The next WebEx session is probably going to be on Thursday. Questions, send them to me and copy Elena on them as well. And the session will go over the random example.
Okay, much.
Thanks, everyone. Elena, yeah?
I stop the recording, right?
Yes. I think I clicked on stop somewhere.
It's still recording, right?